This is a 1946 Clarion model C104A AM tube radio, nicknamed the Waverly. It has 6 tubes, a large 6-inch speaker, and a loop antenna. The condition is pretty rough. The cabinet finish is toast. It has some veneer missing, but on the plus side, it seems to be complete, including the knobs. We will repair this old girl and restore it to working condition. So if this interests you, stay tuned. Alrighty, let's get into this radio, shall we? So it actually has a line cord that's not cut. And this, some sort of antenna. I'll say we'll delete that. Alright, we'll do it the easy way. Alright, it's got a couple screws missing in the bottom. On the back panel. The back panel's in amazingly good shape for the condition of the rest of the radio. Usually these are trashed pretty bad. So let's see here. Uh-oh, looks like we got some mousage.
I hate Mises to pieces.
Action going on in there. Yeah. Let me reposition the camera and I'll show you. Alright, I'm going to have to take this outside and blow some of this crap out of there. Literally. So let me clean it up a bit and we'll be back. Alright, we got the radio out of the case, took it outside, compressed air, blew the mouse house out. It wasn't a lot of mouse house. I think it was a fairly short lease. The mice had inside here and vacated rather quickly, but they did do a little damage along the line. They chewed the dial cord, of course, and they had made their urinal right around there. Luckily, I don't think they pissed on the tuning capacitor, which would be not good. And they chewed on the audio transformer wire there a little bit. But, I mean, it could have been a lot worse. I mean, they could have been in here for weeks, months, years, and just literally ruined the radio. Knock on wood, hopefully it'll be okay. So, yeah. That's unfortunate. And Smokey undoubtedly smells the mouse stuff, so I'm going to do some cleaning on it for a bit. So I don't like working on dirty stuff, especially dirty stuff like this. So I'm going to clean it for a bit and we'll be back. All right, we're back. I got the chassis rudimentary cleaning. A lot nicer to work on when it's a little bit cleaner. Clean the tubes up, and I did notice that this one hopefully the mic's picking that up. I'd say that tube's a dud. So I got a new one for when we get to firing it up. And I did splice in a piece of dial cord so we can tune this. I should probably lube that up a bit. So I haven't looked at the underside yet, so I guess I'll take that off. All right. Let's see. I would say, I don't know. Filter cap's probably been replaced at one point. I don't know. That's probably not factory. That's a newer capacitor. So wait. Yeah, that should be the original filter cap, and someone squirreled in a replacement there, just left the old one in. What else? Does anything jump out? That might be a new. Oh no, that's the same as these, unless those are all replacements, but it's somewhat virgin-y. So, all right. So I think this one, we'll just fire it up and see if it runs. I know that tube is bad, so we'll stick a new tube in. So let me get a few things set up and we'll fire it up. All righty. So I did a little more looking around, and these big tubular electrolytics usually are two separate capacitors in one deal, but in this radio, this is one separate one, and that's the other electrolytic. So we got two in parallel. I can't read what they are, but I assume they're probably, I don't know, 8 or 10 microfarad. So we got a filter here, and one of these is the power resistor. It's probably that one. But anyway, I figure we'll fire it up, see what happens. Try not to burn the house down. So, all right, we'll give it one bulb. Give it some voltage and see what happens. And we'll start with 20 volts AC. Let it simmer for a minute. I have a pretty good streak of forgetting to do stuff when I first power this up, but the speaker is already attached to it, so we'll see what other kind of dumb foolery I can come up with here. And our B plus. Oh, I didn't turn it on. I knew there'd be something. It's always something you forget to do. That's funny. We'll give it 20 volts. Let's see. So the B plus, I'm not 100% sure what that should be. I think 260 volts. I couldn't find it any voltage anywhere on the schematic, but I think I got it. I think it should be around 260-ish volts. So anyway, that's what, 50 some volts. Our first bulb is lit a little bit. I did put the tube in for our broken one. So I don't know if that happened during shipping or what the deal is. So, and let's see, volume. Give it just a little volume. That's about 65 volts. Our dim bulb is not crazy bright, so that's good. Nothing shorted, hopefully. It pretty much will fall over if this radio actually works. So, drawing very little current. But our B plus is coming up in theory. It's got a long way to go to 260 volts. So this is not a particularly rare radio or anything, so I don't mind turning up the gas. I don't know. As slow as that DC voltage is coming up, I don't know. Oh, it can't be humming. Thought I heard something humming. Now let's throttle it up to 100 volts. Actually, our DC voltage is probably really low because these capacitors are toast. That would probably explain it. So let's give it the full onions. Oh no. Oh, there is a little hum coming out of the speaker. Huh. But nowhere near the DC voltage needed. Oh, it is slowly coming up. If I had the patience, I'd probably let it come up a little bit slower, maybe reform those caps. Just stepping on the gas. Hopefully they don't blow up in my face. The speaker is definitely making some noise. Alright, I'll pause it here. I'll let the electrolytics chew on some electrons and report back a little bit. All right, it's only been a couple minutes, but I got to thinking if those the grid capacitor for the output tube is not good, it's going to demolish that tube. So We'll just give it one more bulb here. Well, I don't know. With the bulb, we're restricted to about 90 volts going into it. We'll give it another bulb. Yeah, it's drawing quite a bit of current there. I think we'll shut her down. We'll replace the filter caps and see if we can get some operating DC voltage. So let me do that. We'll be back. Alrighty. We'll get into the filter capacitors. Just do a little deep dive into that. I'll put up the schematic for anyone that wants to follow along here. So we have two filter caps. We got one here and one here. And that is likely the cause of our low DC voltage. I'm sure the other caps are probably leaking and contributing to it, but I think the filters are the main reason. I did kind of look a little closer, and I think all those paper caps are original. The only thing that's been done to this is the hack job on the filter caps. So in our radio, the filter caps are here and here. Those two bad boys. So this is the interesting hack job of there should be one capacitor there. What is it? 16 microfarad. So this is probably, I can't see any markings on it till I take it out of there, but this is probably two in parallel making the 16. So that's kind of a interesting way to do it, but you do with what you have on hand, I guess. So we'll start by replacing those two capacitors. So this is what we're going to use. The schematic is 16 microfarad, 450 volt. I don't believe they make a 16 microfarad, 450 volt, and even if they did, it would be outrageously expensive. So we're just going to put a 22, 450 volt. You could put a 27 microfarad, you could put a 33. It doesn't have to be exact. I remember when I first started doing this, I'd have to get the exact capacitor to go in there. You don't. Just something reasonably close. You don't want to go under. Like that's a 16. You wouldn't want to put a 10 in there. So let's shoe in a couple caps and see what that does for us. Alright, I thought it might be fun to film the cutting out of these crazy paralleled in capacitors. So they're both the ground leads. There's a big solder joint on the chassis, and then they're twisted together. going up here. So we'll just cut these out. Curious to see what value they used. We shall see here on this one. Ah, 10. So 110 microfarad, 450. And we got a spider nest in there, which I think is hopefully vacant. Don't care for spiders. So this one, let's see, what is this one? Oh, an 8. Eight microfarad. So they went with a combined total of 18 microfarad. How daring of them to change from 16 to 18, right?
How dare you!
So this, I guess that's a piece of cloth covered wire that that used to be a strap there. That's interesting. Huh. So actually, I think we'll use the ground point, and or maybe not. I think there's a ground point. Oh, it's just out of frame. Let me see if I can get the camera up a little bit. So this is a ground lug here right above our positive lead, so that would make a nice spot to put our capacitor. Sometimes when you're replacing these filter caps, it's sometimes tough to find a good spot where to put them. But in this case, it looks pretty good. So let me get everything ready to do that. I'll be right back. All right, I decided to just temporarily tack these filters in just in case there's something catastrophically wrong with this. And this way we can just remove this if like an IF transformer is open or tuning capacitor is shot or something like that. So yeah, we'll just leave it temporarily in there. We'll do the one on the bottom and be right back. Okay, this is our other filter cap. Comes out of the rectifier tube to ground. So that is also a replacement. So we'll clip this bad boy out of there. Alright. We can delete this strap. In theory, Wow. Pretty good metal. All right. All right. Oh, and this one is a 16 microfarad. This kind of looks like the original one. I can't believe that it would come from the factory looking like that. I don't know. Maybe. No, I doubt it. I don't know why they wouldn't have put one up in the other spot like that one. But anyway, maybe they only had one left. We'll get set up to squirrel in the other one. As luck would have it, there's a ground lug right here. And this is our original wire, so we'll just tack this one into place. Hopefully with the idea of making it permanent. There we go. So I think I'm going to replace the grid cap on the output tube just to keep from punishing that. So I'll do that, and we'll be ready to fire this thing up again, see what it does. Real quick, I just wanted to show this. So this is our detector audio tube. This is our output tube. And this capacitor here, so the signal comes out to 6SQ7, goes into the 6K6, and there's DC voltage on this side of the capacitor. Capacitor blocks the DC voltage, lets the signal go through to our output tube, and if our capacitor is not capacitating, it lets DC voltage in and can cook your output tube, and that's why it's really important. Filter caps are important, and your grid caps, which this is one of them, your DC blocker for the grid cap, or for the grid connection on the tube. So it's kind of compactly put in there. I'll cut it out and show you how I do paper cap replacements. Okay, so we cut out the capacitor. It's a 0.01 400 volt, and as you can see, it was belching out wax, and it's not in very good shape. Not good for our tube. So I usually use just these type of capacitors, because they're much cheaper than these ones here. These are about 3 times the price, but we got kind of a wide distance between the points, and we use the tubular one. So let's see. This is one stub of wire here. There's another one kind of tough to see right here. So we take our kind of tough to show here. Take our old cap and measure the distance in between. I take a piece of wire here, wrap the leads around it, and solder it in there. And the advantage of doing it this way is it's nice and neat, A, and B, if you need to take it out, all you need to do is heat it up, pull it out. So let me get this ready to solder in there, and it'll make a little more sense. Alright, so here's our finished deal. So sometimes putting these on is a little bit of a trick. So you get one end on, and there we go. Sorry, the light is wiping out the lettering on the capacitor, but I like to have the lettering side out. So you just sneak in there and get some solder going. Solder one end. There we go. There. Nice and neat and secure. Oh, and I did forget to mention, so when you cut the leads off of the old capacitor, you want to take and scrape any wax off there, and then I take a Q-tip and just get it as clean as possible, because you don't want wax on there messing with the integrity of your solder. So all right, let's get it set up to try firing it up again. Alrighty, we have our filter caps in, and our grid capacitor for our output tube. So let's fire this up and see if we get any DC voltage. If I can remember to turn every button on. Let's see, do I have it turned on? Yeah. That's a good sign, I think. Got about 45 volts AC. Crank it up to 60. I'm a little bit irritated this morning. I had a really nice old radio that got destroyed in shipping because the person packaging it had obviously no clue what they were doing. And that's just a shame. It just the cabinet, the finish, it was really a nice radio. So that's why I might sound a little miffed this morning. So we're up to 80 volts. And our DC voltage, now it's going down. Yeah, something's not right. Maybe. As the tube started conducting. Yeah, that must have been it. So we're at 120 volts AC. Give her another bulb. Well, maybe we are good. I don't remember what our DC voltage was on 3 bulbs. I want to say it was like around 125-ish. Well, the hum went away. Yeah, there's some other issue. 190 volts. We're drawing 200 milliamps. So something is draining off our voltage. 190 volts DC should be enough for the radio to work. It could be leaky tubular capacitors. Let's see the yeah, could be that, or we got another bad tube. So let me do a little more investigation and we'll be right back. Okay, I hooked up the loop antenna back here, and I don't know what station that is. I think it's 670, the score, but the radio works. So with 4 bulbs, we have 203 volts of DC voltage. So we know the radio works. So we will proceed on to doing a recap and see if that should hopefully bring up our B+. I mean, some of those capacitors, tubular paper capacitors, are looking pretty grim, so we'll see what that does and we'll be back. Alrighty, it's the next day. I Got all the paper caps replaced. This is the tone cap. I left that in for posterity. So I think our DC voltage with 4 bulbs on our dim bulb tester was 203 volts. So we'll fire it up and see what we got. And our DC voltage is even lower. Oh, I gotta turn up the... I had the Variac. It was down to like 100 and, I don't know, under 120 volts. So yeah, our DC voltage is still too low. I don't think that's because of the dim bulbs.
Striking out with the bases loaded in the 7, and then throwing his bat and his helmet down. Kyle Tucker showing a level of emotion I haven't seen this season. Going back to the dugout and throwing.
So I guess I'll give it full power real quick, see what we got. Oh, that's interesting. Full power killed it. Not quite sure what to make of that. Our voltage came up with no bulb to about 250 volts, which is about right. Let's our volume is way down now. Let's try that again. The tuning string is...
It's like you got the players saying, we're stuck right now, and they're showing it with the body language. The one thing that Crick absolutely true is it's not like they're going out. The weekend's back, everyone's always sad to see it end. Isn't that the truth? Good luck in Williams.
So that's WGN.
Editorial wishing Clarendon Hills kids good luck this afternoon.
The reception is good.
From Las Vegas. What is the over-under on this one?
I wonder if there's a... If the output tube is weak. I don't know. Let me do a little investigating and we'll be back. All right, so I got it on No bulbs, full juice. The B plus, about 250. I think a touch low. So the plate of the output tube is 270, which is high. That should be 250. So I got a feeling our output tube is weak. So let me dig up a 6K6, pop it in there, and see if that fixes it. I don't know why when I gave it the full onions we lost our station, but and the volume seemed to have decreased quite a bit. I don't know if that last bit of juice killed that 6K6, but let me see what I can dig up and I'll be back. All right, we're back. It's been a couple weeks since I worked on this radio. The weather's been really nice outside, so I've been outside doing stuff. So I had some time today to mess around with this, so I figured we'd get back into it. So first thing is the voltages I had labeled on that first schematic I posted was incorrect, and I was trying to read from a poor scan of a Sam's PhotoFact for a C104. It wasn't even a C104A, which is pretty different. But I did find a C105A, which is the same chassis and has the correct voltages. So let me put that up. So our B plus is 260 volts. I think the other schematic had it at 250, so we know what that voltage should be. So with the correct pin voltages on our tubes, addressing the problem of the low volume, I went through and tested all the pins, and the 6SQ7 right here had on the plate should be 85 volts, and I measured 45 volts. So we were losing voltage somewhere along that plate circuit. So we had a couple potential culprits. This 250 picofarad and the tone control capacitor. Now, I think I said earlier on I left that tone control cap in for posterity, and that turned out to be a mistake. So that little bugger there. So our plate voltage is on top there, should be blocked by this capacitor going through here to our tone control to ground. So we'll see what our if there's any leakage there. So we'll fire it up. And let's see. The meter's showing very little DC voltage, but as it turns out, that's because it's going to ground. So the volume's all the way up. So I hadn't messed with the tone control. So if you turn it the other way, our volume comes up. And now we have 22 volts of DC. So our voltage comes through here. It should be being blocked, but anyway, it goes to here and then resistor to ground. So now the pot's at its highest resistance. I think it's like 6 meg. And it's restricting the flow, so we can see our high voltage leakage going through that lousy capacitor, which should be our issue with the low volume. So we'll replace that capacitor and see what we got. Okay, welcome back. It's actually been another 3 weeks since I've worked on this radio. The weather, as I said earlier, has just been absolutely spectacular. So I've been outside getting stuff done, and today it is rainy. So we're inside, and we're gonna try and maybe get this finished today. We'll see. But anyway, replacing that tone cap fixed our low volume issue. So one other thing I did do was replace the dial string, and this is the string that I use, 30-pound Magi braid. It's monofilament braided nylon, which is kind of tough to work with because it's kind of stiff, but it went pretty good. I just ran it. The toughest part is getting the tie off to the spring without the line coming off all the pulleys and whatnot. So what I do is I kind of run it where it needs to go, use Scotch tape to kind of hold it in place, and then take a hemostat and grab it and pull it tight, and then it'll just kind of hang here. You can just let the hemostat hang like so, and then I take the spring and open it up and see about where its widest point is, and then tie the knot off there, and it's working pretty good now. The little splice I put in there kept breaking, so the dial string was in pretty bad shape. So anyway, got that fixed. Maybe someday do a detailed video of how to do one of these. It's kind of hard to do on camera because you got the 57 different angles of the camera needs to be. Maybe I need a GoPro or something to do that. But anyway, so volume issue fixed, the dial cord fixed, the I think hopefully the last problem is the reception is great, except on the upper bands, and the trimmer caps on especially the antenna trimmer. I think it's this one. So these spring connectors go to ground here, and you can see there's rust there. So let me get a closer view with my close-up camera. I'll be right back. Okay, so this is our rust deal. So this is, I have the meter just on beep, and this is ground, and that's ground. It's not making a good connection, but on our tab, it not making good contact to ground. So we need to take this, I think that's copper or brass or something, take that off and clean the rust off where it's just a friction connection to ground there. So we need to clean that up. So hopefully our trim will work on the loop antenna. So let me get set up to do that. Be right back. Okay, we'll get this piece off, and that is pretty rusty. If I can keep from losing the little mica. Oh, crap. I thought these two were connected. So, there we go. I was wondering why when I was testing for ground, I was getting a pretty good one on this one, but not so good on the other one. So what's good to use to clean stuff where you don't really want to scratch it is use an eraser, and that's not too bad. But there is where our trouble is. I need to take this other one off. Oh man, that's tight. Holy cow. Wow. All right. I'm going to leave that on for the moment. I don't want to break that screw off in there. Then we'll, no pun intended, we'll be screwed. So one of these fiberglass brushes works good for cleaning the rust off there. So I'm going to clean this up off camera, and we'll see what we got. All right, we got the rust cleaned off that contact there, and incidentally, these clips are steel, just spring steel. So we should hopefully have good contact now. So I'll put it all together off camera, and we'll see if our trimmer cap works. And this other one, there is a reliable connection to ground there, so I'm not going to mess with that one. That's the oscillator trimmer, and because I don't want to break the screw on that. So let me get it put back together, and we'll see what we got. All right, I got it installed. We have ground contact now, so I have to say this isn't the greatest deal for, you know what? That is, looking at that now, that's, yeah, that's broken. That was one piece. So I wonder if I could solder that. Let me think about that for a sec. I'll be right back. So upon thinking about this, I can't solder it because Well, I would think the heat will wreck that mica wafer in there. And since I can't get the screw out of the other side, I could just take both the mica wafers off and then solder it. Yeah, it's not an ideal situation. We'll power it up and see if the trimmer cap works. And if it does, we'll just leave it be. If it doesn't, I may try putting some penetrating oil on that screw and taking the other one off. So let's power it up and see what we got. So I have just a ground lead to that, and now we get the upper band, and when we lose the ground, we lose our trimmer. So I'm gonna have to take that screw out of there, hopefully without breaking it. So I'm going to soak it with some penetrating oil, and I don't know if I'll bend a new piece or try soldering that. We'll see, but I'll check back when I get it off. Alrighty, I managed to get the screw out of the other side of that trimmer cap, and I made this little jig to hold everything in place to weld these two, or not weld, solder these two pieces together. And incidentally, here and here there were cracks on that darn piece of metal, so I reinforced it with a little solder. I don't know after I try to put this on, flexing it is going to break or if it's going to work. I have a plan B in mind, but we'll give this a try. Okay, I got the spring clip mounted back on there. I had to run a ground wire from the spring clip to ground because it wasn't making good contact there. Since it's soldered, it doesn't have any like springy tight grip on that case there of the tuning capacitor. So the radio works good on the low bands, but not so good on the high bands. So I noticed that this is the oscillator and the RF trimmer were all tightened all the way down. And when I checked the tuner fully open at supposed to be 1725 kilohertz, it's off quite a bit and ran out of adjustment on the oscillator. So I think I'm going to try wiring in a small capacitor in parallel with that trimmer, see if we can get the dial straightened out and see if that fixes anything. And I've checked these all might need capacitors paralleled in there. I don't know if that oscillator coil is what's going on with that, but we need to look into it. So let me get it set up. I'll be back. Okay, so this is our oscillator trimmer here, and I have the tuning capacitor fully open, and according to the instructions, you set your signal generator to 1725, and we have no tone. So tightening the screw increases the capacitance, and we're out of adjustment. We can't pick up 1725. So there it is, tightened all the way. So we're at about 1890. So since we're out of capacitance, I have a 5 picofarad capacitor. We'll just put in parallel here. And let's see what we got. Yeah, we're down to 1725. All right. So we can peak that now. And I did notice now the upper stations are coming in. There they were. There we go.
Into this house we're born.
So with the tracking being off on the oscillator, that was definitely not helping things. So I'm not sure why this is like it is, why we're out of adjustment on there. My suspicion is that oscillator coil is, I don't know if it got damaged or just what the deal is, but all these trimmers were tightened in all the way. So we'll start by fixing this one. I'll solder a capacitor in there, and then we'll go on to the antenna trimmer. All right, I got our capacitor soldered in there. I'll show you a close-up real quick. There she is. So it was kind of tough to get it soldered to stick to that rusty lug up there, but putting that in, now all these trimmers are adjustable. I get the local high band station comes in nice and clear. So this video is getting absurdly long. I did a quick alignment off camera. It was pretty much spot on. Just adjusted the antenna and RF trimmer, and it's pretty sensitive now. It's not bad. I mean, this repair work is not the prettiest thing in the world, but now the radio is fully functional. So I'll get it back together. We'll have some final thoughts. Alrighty, I got it back together. I don't have it screwed together and whatnot because I'm going to redo the case eventually. But as it turns out, this is a pretty good performing radio. I have the light off so you can see the dial. Let's see. Gets local station 1420. Let's see. Get something there. I don't know what that is. AM 1000. That's should be WLS.
Your direction when you're in the Kennedy, or if that's where you're headed.
That's 820. Don't know what that is.
Your review of your song and the lyrics said
WGN. 670 the score.
Focused on one thing, bringing you affordable,
It
reliable.
it's pretty impressive. That spring clip that we repaired on the tuning capacitor, I'd like to find one off a scrap tuning cap one day, because that it's kind of flattened out and doesn't have any spring to it, so there's not a whole lot of good adjustment in it. The oscillator does good, but the antenna trimmer could stand a little more oomph to it. But nevertheless, we got it working, and it works all in all really good for what it is. So, I mean, we didn't do a whole lot to it. When we started out, it had that bad tube that when I shook it, it rattled and was making noise. So we did the usual filter recap and the paper caps, and I didn't do that tone control initially because that usually doesn't play into anything, but that had an important DC component on it, and was leaking. So we fixed that, and our dial string, put a new one on there. That wasn't too bad. But the tuning cap, that spring clip for the trimmers, I guess, was the main thing, and we fixed it good enough to get it to work. So that's all we're really interested in this part of the video. I want to start getting into some cabinet restorations. I've been doing a lot of looking into different methods and whatnot to do that, so hopefully get those going pretty soon. But we'll call this radio mechanically good, except for a new spring clip eventually for the trimmer, and performs real good. It could probably use all new tubes. They were, like I said, that one was broken, and it could probably do better with a fresh set, but that will be for another day. So anyway, I hope you enjoyed the video. Hope you maybe learned a thing or two, and thanks for watching.